Hey everyone, welcome back to my channel. Today I'm going to show how to implement factory design pattern without violating solid principle. The main reason I am doing this tutorial because I saw so many videos and tutorial which show how to implement factory design pattern but which violate open close principle. That's why main reason I am doing this tutorial. So all the source code related to this video you can find in the description below, which is in the GitHub repository. Plus I'm supposed to do a mini video in the future. If you like my content, please like and subscribe. Thank you so much. Let's get in. First of all, see how a conventional way of implementing factory method which violate open close principle. So this application very straight application, very simple one. You can see what does it do. It's based on the input type. It's calculate the tax amount. Let's say, for example, if you get the if it's a, you are the individual, it's calculate the different tax, and if you are company, it's based on the company. It's a calculate different amount of tax. The classes structure is very simple. We do have a tax controller, whereas the actual endpoint, and whenever we get the request, it come called the tax calculation service. So calculation service is basically called the calculate factory, where it give a instance of I calculator. Based on the type of I calculator, it could call individual calculator or it could call a company. As you can see, the individual calculator and company calculator are inherited. It's a concrete class of L calculator service. So this is diagram. Now let's see how this implemented in .NET Core. So as I mentioned, this is not a specific .NET Core. The concept is pretty standard for every. It's a technology agnostic, right? Let's see the convention of implementing the class and the structure. So first of all, we will go to the this is a .NET Core web app application. It's the simple standard controller. It has a class of services, and that's all. For the sake of simplicity, I didn't create a separated library for the services, and I create everything on the single class, single library, I would say. But in the actual real environment, you need to separate this into separate library. Right. Let's go to the controller. This is where actual actual endpoint where the user requesting. We do have a one endpoint. As you can see, it's a calculate, which accepting a string and the amount. The string could be individual or company. As I mentioned, it could be string type is individual tax or company. As then what we do, we got the injection, we get the calculation tax calculation service interface. What we do, we call the calculate tax and pass this parameter. So let's go to the services, and this is the interface. Let's go to the implementation. So as you can see, this calculator tax method in the iCalculator service. What does it do? It's called the factory. This is a factory, calculate factory. We get the instance of calculator, because based on the type we need to get the instance of calculator. Let's go to the get calculator. Right. I put the same interface in the same file for just the sake of simplicity again. In the calculator service, what does it have? It has a get calculator. Based on the type, it's return iCalculator interface. Let's say, for example, type is individual. It's written in the individual calculator. If it's a company, it's written in the company calculator. Right. So if we go to the calculators, let's go to the calculators. These are the two calculators currently have: individual, pretty straight, and get the amount times by 10 and divide by 100. So if it is company, its company is a little bit more taxes. It says get the amount times 20 divide by 100, and this is iCalculator, just the interface, right? So this is how usual factory method implemented. So what's going to happen? Let's say, okay, we need to get another calculator. Let's say someone come and ask, okay, we need to do different kind of calculating. Let's say it's not a individual, it's not a company. It's, think about it, let's say hybrid. Okay, so how do we do this? That's where we, if you implement it in this conventional way, that's where you break the open close principle. So if you want to implement another calculator, so usually what we do, if we go with the conventional, we need to add another calculator. That's what people do. Let's say copy, I'll add another calculator. Let's say hybrid. Let's say hybrid H capital. Copy, and I'll come here and yeah. Right. Let's say the hybrid calculator is 15%. It's in the middle. Right. So that's fine. You add in the new calculator. That's fine. It doesn't violate the open close principle because it's open for extension. It's extension. But you have to change in the calculator factory. So what you need to do, you need to come over here and you need to add another case. It says hybrid. So if it is hybrid, then you call hybrid calculator. This is how you implement if you want to add a new calculator. This is breaking the open close principle, right? So but what really we want, we don't need to change what we need. We don't need to do any changes in the factory method, factory class. So it should be whenever you add a new type, it should automatically pick up. That's something we're gonna write, and from the scratch, and you will get a better understanding how do we implement this factory method in without violating open close principle. Let's get in. The very first thing what we need to do, we need to bit of magic in startup. Let's go to the startup class. And so what you can see in the startup class, currently we registered iCalculator service and iCalculator factory. So now what we need to do, we need to register all the iCalculators. So if we register in the startup all the iCalculators, and whenever someone add a new calculator, it should pick up automatically and we don't need to do anything. So let's see how do we do that, right? So one thing we can do, we will add another class. You can use any ID. Currently I'm using Rider. You can use VS Code or Visual Studio or whatever your favorite editor. So we will create a extension. Let's say a service extension, right? What is service extension? I'll come to here. So basically, let's say service collection extension. So what does it do? I can put all the registration over here, but it's making separation is really good. That's why I create a separate class. So what in the service collection, we will create a public static void. What we're gonna do, we call it this one should be static, because we're gonna do a bit of adding a middleware. So we will say let's call it register all calculator types. Then we can do, so when we do the register, we will say it's a T. I'll come to here. So then this method we can use to register any type of interfaces. So it's not calculator, we can call it all yeah, we keep it the calculator, but you can use for any other types too. That's why I use a T. So in here what we're going to do, because this is an extension method for the iService collection, service collection, get the service, we call it services, and we get assembly, list of assembly. This is assembly, right? then we can call it, we can get a service. I'll copy the method, we don't need to do the default parameters of transition. So in here what we're gonna do inside, we register all the type. So I'll copy this one and go through, get the reference. I'll make it a little bit bigger, and let's say, yeah, cool, now it's look good. Right, I'll get the stuff done. Right, so keep it. So what we do, we get the based on the assembly type it's sending, we get the all the interfaces for particular type. You can see it's a particular type, and we get, in this case we get all the concreters class. For example, if we send the t as iCalculator, it gets all the implementation of the iCalculators, and it's added as a service. So how do we use this one? If we go to we copy this and go to the register, and over here what we're gonna call services dot, come to the services class, then what we call register all type. So over here what we passing iCalculator, because we need to get all the iCalculator, we need to register all the iCalculators, and we need to pass another thing. We need to say assembly. So we need to find all the assembly in startup class. Basically, where the wherever the startup class sits, we need to get all the assembly and its assembly, and then we need to pass the what's the lifetime, service lifetime. So we will send a lifetime scope as a default, right? So this is something you need to do for register all the iCalculators. Whenever new calculator add, it's get automatically registered without doing anything, right? So if we go to here, so that's the method. That's the one of the simple method we need to add. Then what we need to do, let's go to service class, right? Let's go to the factory. So we do have a hybrid, right? We already hybrid, and then we go to the calculator factory. So we need to do here, we need to do a bit of cleanup. So what we need to do, we don't need to do any hard-coded the string or anything. We don't need to do that. So what we need to do, we first need to go with the iCalculator. Let's go to the iCalculator. We need a bit of change. The first thing is we need to add parameters, the property call name. It's a get method, and that's all, right? So then we need to as we added the new property, we need to go and have a go to the iCalculator. We need to go implement this string. Let's say this should be the individual, the name should be individual. This one, let's go, because this is a hybrid, this is let's say hybrid, and company, say company, this one should be company, right? So all the classes, all the iCalculators are implement this name. Then pretty much we done. If we go to the calculator factory, so just one simple change you need to do. So what we need to do, so over here calculator factory, so what we need to do, we need to get a ctr, that's a shortcut for creating a constructor. If you don't know, what we need to do, we need to get the enumerable iCalculator. So as we over here in the startup, we are adding multiple iCalculators. So we need to get all the iCalculators into factory. So get the enumerable, get the missing, and over here what we will create a you can use if you use in Rider, you can just create only field easily. Then what we're gonna do, rather than here, we don't need to do anything of this bit. What we need to do, this is everything is get calculated automatically, or the get the calculator type automatically. What we do, let's say calculator, and it is because based on the type we will get the right name is this, then type dot to lower right. This is where what's going to happen, some of the type we going through all the calculators and then pick up the right calculator. So then what we do, it's easy, we can do some check, because if it's a new calculator which is not which the type is not right, so they haven't, let's say the new calculator they added, it's not implemented this name, so we can give us some not null. If it is not null, maybe null, can throw new implementation, so we can throw new implementation, otherwise we return calculators. Right, that's pretty much you want to do. What is calculator? Yeah, I'll change it the name a little bit, refactoring. Right, so that's a change you want to do. Let's see what we have done quickly. We register all the iCalculators, so you can see it's an extension method for the iService collection, and the iCalculator come with, we added a new property for the name, and then the calculator in the factory, this is the change we did. Right, let's see now, let's run this and let's see how this is working. Right, if we go right, so this is, I'm using Swagger, so you can see there are many. Okay, let's try out quick one. Let's say it's an individual, and this is 1000, and you can see, or it's internal error, method operation is not implement. Okay, okay, extra I, so you can see it's 100. If we say company, it should be 200s, and if it's a hybrid, it should be 150. That's fine. It's work as it. Let's say now it's a perfect way of implementing the factory method without violating open close principle. Why I'm saying that, let's say you want to add another calculator. Let's say you want a calculator simple, let's say simple calculator, or complex calculator, you want to more complex calculator. Copy that, right? Let's say go to change it, because you are adding the new calculator. Yes, of course it's extension, you want to add the calculator, right? So then what we need to do, you want to do complex calculation. Let's say you want to do total, I want to make it more complex. Let's say time 10 divided by 100, and then let's say that reduce $20, let's say, right? Then we say pass total. Right, that's all you want to do. Let's build it. Okay, then you need to change this one as a complex, then build it, and then run it. Let's see how does it look like. Right, cool. If we got this, and we'll try that individual, let's say again the amount is 1000. I'll get more space. Yeah, it's a 100, and let's say company 200 hybrid let's say hybrid. I can't write hybrid, I can't spell hybrid. 150, let's say complex as a 80, right? So it's perfectly work. You don't need to do any changes. The only changes you have done, you added a new calculator, that's all. So everything is work charm and without violating open close principle. Um, yeah, that's pretty much all the code source available in a description below, and you can refer the github repository. Hope you enjoy, and if you have any question, please comment below, and please if you like my content and if you enjoy, please like and subscribe. Thank you so much. Yeah, before I go, I hope to do some hands-on design pattern on in future. So if you guys have any specific design pattern need to discuss yours, please comment below. Thank you so much. Have a good day.